Hello everybody, I am Ben from Team Panic, and today we have another Will It Bot episode, and we have this. The head, or the spare head, from Shark Satrakian, who is one of the Bugglebot's Season 2 competitors. Now, before we get too far into this, I will dispel any spoilers you may be thinking of. This was given to me post-Bugglebots Season 2 by Dave, the builder of Shark Satrakian. It was not a trophy for winning a fight or destroying anything. So, yeah, I can't confirm or deny whether or not we had a fight at Bugglebot Season 2. You have to watch Season 2 to find out, but I can say that this was just a gift. It is not a trophy. So, it's been a little while since we've done a Will It Bot here on the channel, so I'll quickly refresh you guys on the rules. At the end of this, the shark needs to be a valid combat robot in a valid weight class, so we're going to go for the 150 gram ant weight class, because this guy has already been a beetle weight, so we're going to push that down into the ant weight class. It needs to retain some of the look of the shark, and it also needs to have an active weapon of some kind. Now, those are the main three rules for any Will It Bot episode, but today we're also adding the jellyfish clause to the end of that, because Dave is not only the builder of Shark Satrakian, he's also notable as the builder of Jellyfish, a heavyweight combat robot that competed at Robot Wars. Now, Jellyfish is an awesome robot because the whole design concept behind it was that anybody should and can get into combat robots. Jellyfish was built with a limited set of tools to show that it is a sport that anybody can get into, and I love that idea. So today we're going to be building this combat robot with the same tools that Jellyfish used, and I'll let Dave himself tell you what those tools are.
The entire robot has been built with basically a jigsaw, a drill, a soldering iron, a screwdriver, and a hammer.
So that is quite a limited set, but it is possible. We are going to change out the jigsaw for a Dremel, just because it's going to be better at this smaller size to use a Dremel rather than a jigsaw. But other than that, that's the tools that we're going to use. So there's going to be no 3D modeling, there's going to be no 3D printing, which is going to be tough for me because those two things are how I build ant weights. So I'm looking forward to this. This should be a good challenge. And yeah, it's going to hopefully show you guys that you can still build ant weights even without all of that stuff. So let's get started. The first thing we think we need to do is weigh this guy, because this is a rubber hand puppet thing. It's very resilient, but it does feel quite weighty. So let's get it on the scale. Oh, ouch. So that is 100 grams of shark head, which means we either need to build a 50 gram robot to jam in underneath it that somehow has a weapon, or we need to go another route and we need to get some extra weight. Now, the ways that we can do this are to build a shuffler or a walker. So a shuffler is a robot that uses a cam actuation or a motor running in one direction to move forwards without wheels on the outside, or a walker which uses 2 points of articulation, so not just a motor running in one direction, it's two or more motors running in different directions to get the robot to walk forwards. So a shuffler gives us a 50% weight bonus and a walker gives us a 100% weight bonus. So a shuffler puts us up to 225, I believe, and a walker puts us up to 300 grams. Now, given the tools and everything that I have available to me for this challenge, I think we're going to go for a shuffler. And in fact, we're going to go for a Bristlebot shuffler, which is essentially using brushes in underneath the robot and some form of vibration to get the robot to move along. So I'm going to do something that I haven't done before, despite the fact that I have been a kind of STEM educator, or I volunteered as a STEM educator for a while. We're going to build a Bristlebot. Now, for those of you who don't know what those are, you take toothbrushes like the ones that I have here, and you stick a motor from a phone, the little buzzing motor out of a phone, on the back of them with a battery, and you get a little Bristlebot. So we're going to use these as a quick tester to work out speed and pushing power and that type of thing from a Bristlebot to see if this is a valid idea for our old shark head. Okay, so here is our little BristleBot. Let's first of all make sure that this thing works. Turn it on with a switch at the top. Up, and it's going backwards to the way I thought it would go. That is really quite interesting. But this is why we did this. So the bristles seem to work pretty well just in the regular toothbrush, although there is a tiny amount of curve to it, which I'm not exactly happy with. Yeah, so if I put it down, it kind of curves back towards the camera a little bit. Not a huge amount, but it does curve. But this is why we did this. So the idea is that cutting these bristles should allow us to change the direction of motion, or at least help fix a little bit of this wobble that's going on in it. Of course, I added a googly eye to the front of it because everything looks better with googly eyes. There we go. That's relatively straight, but still not perfect. Okay, let me give this guy a bit of a cut, and we'll see if we can get that to work a little bit better. Okay, so our little VibroBot is all trimmed up, and it's a success and a fail. So I trimmed the bristles so that the nose is down, and it does now move forwards, but as you can see, it also kind of moves around and has a tendency to fall on one side, and yeah, I think I made it worse rather than better by trying to trim those bristles down. So I think, and it's literally just because trying to trim toothbrush bristles is actually quite a challenging task. They don't like to stay in place and get cut, they like to move rather than get cut. Yeah, so I basically destroyed this BristleBot. But it has taught me that we're just going to have to stick with the toothbrush bristles as they are, or at least that's going to be the easiest way to do this, because otherwise our poor little BristleBot is going to run around in circles. So I think it's time to grab some stuff and start on the design for our shark. Okay, so here's the plan. We've got the shark and we are going to run a servo motor up in the guts, up in the back here somewhere, to open and close the mouth, rah, 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 like so. And we are going to try the BristleBot strategy. I didn't have too much success with our little buddy, but I think I can fix that by just not cutting the bristles down on the toothbrushes. So we're going to use tiny little brushless motors. These things spin incredibly fast, so we shouldn't need to unbalance the things on top of them too much to get them to provide enough vibration for this. I've got a couple of tiny little props here which we're going to cut the fins of the propeller off of, and that should just leave us a little bit of plastic which will unbalance everything, and if it's not unbalanced enough we can stick some screws in there or something to really get some unbalancing going. So we've got two of those, one on each side of the robot, sitting above the toothbrush handles or toothbrush heads, which will then cause the thing to vibrate along, fingers crossed. That's the current plan at least, and then of course we've got some electronics around here that will get all this stuff moving, including this guy, which is the Arduino stack set up out of the boat, the air-powered boat that I made a little while ago. This is going to be perfect for this use because it's basically programmed exactly the way we need it already, and it's smothered in hot glue, so that would be perfect. And then of course we've got some plastic down the bottom here that we're going to build the base of the thing out of. So now that we know the plan, it is time to do a little bit of CAD, some cardboard aided design this time round. So we need to get a decent idea of the shapes that we need to cut out of our plastic, so cardboard is going to help us out with that. So the first thing I need to do is kind of work out just how wide Sharky is, and then kind of double check my motors and stuff, because I need to be able to fit these things in here and have them not collide with any of the electronics or anything I also want to stack in here. So I might actually cut these propellers down, or maybe we'll just run off of the motor that doesn't have a propeller on it, wherever that's gone. Here it is, tiny little thing. So we'll work something out. I'll do some CAD design here, and we'll see if we can actually fit everything I want to inside of this little guy. And this is why you CAD design, well, at least this is why I'm CAD designing. It's taken me 3 attempts to get to something that I think is going to work. So I started out trying to go kind of low and wide, and I think what we're actually going to end up with is thin and tall like this. It actually suits the shape of the shark better too. The shark, I originally stretched it out when I was doing the initial measurements, and that's how I came up with a low-wide design. But realistically, it's going to sit more like this, which is actually thinner and taller. So this is our new design. It's come with a few different upgrades over the old design. The original design, we're going to have these flaps that had the brushless motors kind of hanging off the back of them. Not sure if I can show this on camera. Yeah, like that. And I've realized that I don't actually need to mount my motors this way. I can just mount my motors flat, and the vibration is still going to work the way I want it to. So that's going to save me a whole lot of hassle. So the next step is to convert this little cardboard template into some HIPS plastic, and then we're going to have to find out some way of melting this stuff, because this is 2 mil thick HIPS, so it's quite sturdy stuff. We'll probably just, I think, use a lighter and heat this stuff up, and hopefully it will bend. It is designed for, or it is used a lot for vacuum forming, so it should heat and change shape pretty easily, but something we're going to have a look at. Alright, so with the chassis now somewhat in shape, and also the electronics done, I've got all of that soldered all up and wired together, it is time to get the final pieces together. So, first things first, we need some holes in Sharky so that we can put some bolts in and bolt Sharky to the front of the robot. That was harder than expected, but that is now done. We've got some bolts in through Sharky, so that can be bolted in there. We also need to cut down a couple more toothbrushes to go underneath the robot, like so. And then finally, we need to cut down some other bits and pieces that will also go in the robot. And also done. Okay. I think it is time to start on the final assembly. So let's get the glue gun hot and get going. Okay, so that is Sharky pretty much done now. Everything's kind of just held in place, essentially. We do need to make a top cover, but the first thing we need to actually work out is weight. So we have 225 grams, and we are at 220. Yes! Perfect. So we actually can add a top cover, but I'm not going to do that in this video, I don't think. What I think we need to do now, well, we need to turn this on and make sure that everything still works while being jammed up inside here. And then we're going to take it into the other room and we are going to actually do a test drive. But like I said, first we're going to turn this on here on camera so that if anything smokes, you guys get to see that as well. Here we go. Actually, I'm going to turn the controller on first. Always a good idea. 3, 2, 1. Yes. So the mouth works. That's a good start. All right, let's go into the other room and see what happens when we try and run this thing and do an actual drive test. Okay, it is time for a full systems test. We have the remote powered up. Let's power up the Shark. Get the mouth all the way up. Oh, that servo's straining a little bit. And here we go. Time to drive. 3, 2, 1. Oh. Whoa. Okay. Oh, I got a drifty Shark. Oh no! It doesn't drive forwards. If I try and drive forwards... Whoa! Oh, what's going on there? One of them makes him drift sideways and one of them makes him spin on the spot. Oh, it's also really, really loud too. Okay, I'm going to see if I can just get the brushes a little bit aligned better and maybe sand down the front wedge. See if that'll fix whatever is going on here. Okay, so I've had a bit of a play around with it now, and I think the issue is that the brushes aren't quite even. So this brush on this side hits the floor properly, and this is the one that actually works. And then if we turn it around to the other side, you'll barely be able to see this. So we've got the back part of this brush touches the floor, but nothing else touches the floor, which is why we get the kind of sideways drift out of it. So there's not much I can do about that right now. I'm going to try and fix this between this video and whenever I fight Sharky, because Sharky is definitely going in a fight, but I can't fix that right now. I'm kind of out of time for this video. But Sharky does work, and also in messing around, I found one other little party trick that Sharky here can do. So let's turn Sharky back on, and I found this. So if we go like... By opening and closing the mouth, because we're running on a Bristlebot design, we actually get movement. We get backwards and kind of sideways movement out of Sharky by opening and closing the mouth. No motors or no brushless motors required. Look at this. Here we go. Around, all the way around. And he's actually got a pretty decent range of bite motion here. The servo doesn't like it going all the way up. It really does complain when you start going too high. But, oh, it's just hilarious. I love it so much. Yeah, it would just be nice if it actually could drive forwards properly. But we'll get there. We definitely will get there. And the other problem too is it's only got a forwards at the moment, and I mean it will only ever have a forwards, and I keep trying to pull backwards on the stick to correct its position on the table, and it's just, it doesn't do that. So yeah, there you go. The sideways drift kills me. It's hilarious. Look, so If I try and turn one way, it just drifts. Whee! But yeah, so that tells you though that yeah, this brush is not connecting properly, and what it's actually turning on is the little wedgelet out the front here. So I did have to kind of pull Sharky's jaw back a little bit, so I've got a little bit of a wedgelet, but the internal plastic piece in here goes all the way out to there. So in theory, we can actually grab hold of a robot on this kind of, yeah, little wedgelet out the front here. So like I said, I've got a little bit left to do on Sharky, but I think I'm going to do all of that between videos at this point. And there you go! Sharky is done-ish. Like I said, there's some tweaking that needs to be done on Sharky before it goes into a fight, but I will do that between videos and all that kind of stuff. Huge, huge thank you to Dave for giving me the shark head and making this madness possible. This thing is possibly one of my favorite things I've ever built at this point in time. Yeah, I love it to pieces. But yes, you will definitely be seeing the shark on this channel again in the future. I will try and fix those issues and get it into a fight, and then we'll have some fight recaps with the shark. Yes, I'm so excited, and I am so very keen. So I hope you guys have enjoyed that one as much as I have, and I will see you in the next video. Da 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 do 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 da 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 do 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 da 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 do 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 da da da.